Hello everyone, this is Gianluca and welcome to your Data Teacher podcast. In this episode I'm going to talk about neural networks and how to explain them. As we know, neural networks are very similar to black boxes, and when we train a neural network we have to optimize some cost function according to a very huge number of weights and biases, and the way a neural network is able to learn and the way we can explain how it represents data internally is very difficult to explain, and it's very difficult to get. Neural networks are black boxes, and explaining their behavior and their way of thinking and modeling the data is very difficult. There are several models in machine learning that are able to give us their own interpretation, for example, of feature importance. These models are, for example, the linear models and the tree-based models like random forest or gradient boosting decision trees. Neural networks are not able to give us their own interpretation of feature importance. Feature importance is a very useful tool when we want to explain a model, because knowing the interpretation of the importance of the features according to a model gives us a better overview of how a model is able to extract the information from the data. And extracting information from data is exactly what a data scientist must do. So when a model is not able to give us its own interpretation of feature importance, is a great problem for us. So we have to explain this model extracting feature importance using some other technique. I have published an article some weeks ago about a very useful technique that is called SHAP. SHAP is a technique that tries to calculate the marginal contribution of a feature to a target variable, combining this feature with all the possible subsets of features a dataset can be made of. So the idea is that the output of a model is not only related to one feature, but the marginal contribution of that feature is somehow related to the other features as well. So the idea behind SHAP is a game theory idea, and it is like any feature works in some particular way because there are other features. So using some combinatorics and some calculus, SHAP is a technique that is able to give us the importance of a feature according to a given model, independently from the model. This is called a model agnostic approach. So using SHAP we can calculate the impact of a feature over a target variable independently from the model. SHAP doesn't need to know the type of model we are working with. It can work with tree-based models, it can work with neural networks, with linear models, whichever model we want. SHAP is able to give us how much a feature affects the value of the target variable according to that particular model. It is a very useful technique, and it can be used even for neural networks. So we can use this technique to explain a neural network better. So uncovering the black box that is represented by a neural network. SHAP is a technique that has been introduced quite recently, and it is computationally expensive. So in Python there is a very nice representation, very nice implementation of this technique that has some particular computational optimization. There is a quite optimized version of SHAP calculation for tree-based models, and there is another implementation for any particular kind of model we can work with. So my suggestion is to always use SHAP because it gives us the impact of a feature according to the other set of features. There are several graphical representations of feature importance according to a given dataset and according even to a single record. Given a particular record, SHAP can give us its own interpretation of how the features work together to give us a particular value of the target variable. The idea is that the value of the target variable is the sum of the marginal contributions of the single features according to particular weights to these contributions and according to all the set of the features. So I really like using SHAP to explain the models and to explain neural networks, and I find that this technique is very powerful and very useful. It works both for scikit-learn and for Keras estimators. So my suggestion is to study this technique and to apply it every time we end with the training of a model. After we have tested the model in the test dataset and we figured out that the model is able to work and is able to be deployed in production, we must explain this model, for example, using SHAP technique. Thanks for listening to this episode, and I hope to see you again on my website, yourdatateacher.com.